So the main issue with Dalton's atomic theory was it was not able to explain Gay-Lussac's law of equal volumes of gases. So Berzelius in 1811 came up with a hypothesis which is called as Berzelius hypothesis, according to which equal volumes of all gases contain equal number of atoms under similar conditions of temperature and pressure, which meant that equal volumes will have the equal volume of gases will have equal number of atoms under similar conditions of temperature as well as pressure. So let's take an example. In Gay-Lussac's law of gaseous volumes, we had taken hydrogen reacts with chlorine to form hydrogen chloride. Okay, so according to that, first of all these three are gases. So all of them are gases. So here we have one volume of hydrogen reacting with one volume of chlorine to give us 2 volumes of hydrogen chloride. So this has been explained in Gay-Lussac's law. If you've not checked the video out, do check it out. So according to the Berzelius hypothesis, equal volumes of gases consist of equal number of atoms. So since these two have equal volumes, suppose hydrogen has n atoms, number of atoms, okay, as n. Chlorine should also have n number of atoms. But because you have hydrogen chloride having 2 volumes of the product, basically, this will mean it has 2n number of atoms, which means if this was 1, number of atoms of chlorine also becomes 1, whereas hydrogen chloride number of atoms becomes 2. Now assume we want only 1 atom of hydrogen chloride, then this will be 1, this will be 1 by 2, and this will be 1 by 2, because we are dividing it by the whole thing by 2. But according to Dalton's atomic theory, it is impossible for fractions of atoms to undergo a chemical reaction. This meant that the Berzelius hypothesis about equal volumes of all gases containing equal number of atoms was wrong. So there had to be something that had to be changed. That's when Avogadro came in. So according to Avogadro, he said that there are two particles which are the two smallest particles which exist. One of them is a molecule, the other is an atom. So there are two types of particles which exist, atoms and molecules. Remember, this was at a time when not a lot of information was available about atoms and molecules. So this was an entirely new concept for people. So according to Avogadro, the smallest particle of an element which may or may not have independent existence and takes part in a chemical reaction is an atom. So let's take an example. Okay, so we'll start with atom. Now let's talk about hydrogen atom. When I write it as H, it means it is only one atom of hydrogen. Now this atom may or may not exist. So definition is atoms may or may not have independent existence. But hydrogen does not exist independently. So this is an atom of hydrogen. Next, atom of oxygen. When I just write it as O, it is an atom of oxygen. When I write it as Cl, it is an atom of chlorine. When we talk about inert gases or noble gases, He, helium has independent existence, which means it can exist independently. So, but even then it is a atom because it is the smallest particle. Helium, neon. So all of these are examples of atoms. So you need to remember atoms may or may not have independent existence, but they take part in a chemical reaction. Molecules, on the other hand, are the smallest particle of a substance. Here they've mentioned the word element. There we told element, and which means only one type, whereas substance can mean it's an element or a compound. Remember our classification of matter, nature of matter. Under the chemical classification, you had element and compound. So, smallest particle of a substance which can exist independently. So, under molecules, first of all, you have two types, homoatomic and heteroatomic. First of all, molecules can exist independently, which means they have independent existence. Atoms don't have independent existence. So, molecules can either be homoatomic or heteroatomic. Okay, homoatomic examples are H2, Cl2, Br2. Okay, all of these are homoatomic molecules, which means they have only one type of atoms present in them. Here you have two atoms of hydrogen. Here you have two atoms of chlorine. Here you have two atoms of bromine. Okay, so homoatomic molecules are further classified into mono, di, tri, and poly. Oh, sorry, tetra. Tetra and poly. So, monoatomic means they can exist independently. So, He. So, these are monoatomic, whereas diatomic is H2, Cl2, etc. Triatomic is ozone, O3. Tetraatomic is P4, tetra 4, P4. And example of polyatomic is S8. So here homoatomic is, it has only one type of element in them. These molecules have only one type of element. They are classified further to give us monoatomic, diatomic, triatomic, tetraatomic and polyatomic. Mono means 1, di means 2, tri means 3, tetra is 4 and poly is more than 4. Now, heteroatomic, on the other hand, will have more than one kind of atom, which means H2O, HCl, HBr, H2SO4. All of these molecules have more than one element present in them, which means they are heteroatomic. Okay, so according to Avogadro, again this was in the early part of the 19th century, where they did not have a lot of clarity as to what atoms were in the first place. He gave two definitions, that the smallest particle of an element which may or may not have independent existence is an atom. These may or may not have independent existence, whereas molecules are the smallest particle of a substance which is capable of existing independently. One thing you need to remember, in case of molecule, he's using the word substance, which means that substance can be an element or it can be a compound. So he had come up with this definition for atoms and molecules. So with respect to this, he came up. So he could be. So what was done was they considered molecules to be polyatomic, and then came up with the law called as the Avogadro's law. So under similar conditions of temperature and pressure, the equal volumes of all gases contain equal number of molecules. Here he said equal number of atoms, and that was removed and we put in the word equal number of molecules. Okay, so here the volume is directly proportional to the number of molecules. For example, if we have hydrogen, oxygen and chlorine, okay, they are present in the same flask, same sized flask. So all the three flasks have the same capacity. Okay, and you have chlorine, oxygen and hydrogen. Notice I am not writing it as HCl and O. I am writing it as Cl2, O2 and H2 because these exist in their molecular form. These have independent existence. So according to this law, the number of molecules of oxygen, hydrogen and chlorine is going to be the same in the three flasks because the volume of the three flasks are the same. Remember I told you about the volume of gases. So volume of the gas is with relation to the container itself. Okay, so here we are taking the same sized container, which means this container will have the same volume. So the number of atoms, I'm so sorry, here you need to use the word number of molecules. So the number of molecules of chlorine is equal to the number of molecules of oxygen will be equal to the number of molecules of hydrogen. And this is what was given by Avogadro's law. Now let's take the example of formation of water. Okay, so here you have H2 plus O2 gives rise to 2H2O. I'm supposed to write 2H2 plus O2 gives rise to 2H2O. According to Gay-Lussac's law, you have two. Let's write in the corner. One moment. So let's consider the volume. So two volumes of hydrogen reacts with one volume of oxygen to give us two volumes of water, which means number of molecules or maybe I'll do one thing. I'll write it here for better understanding. Okay, much better. Okay, so 2H2 plus O2 gives rise to 2H2O. This is what we studied in Gay-Lussac's law. Now, here you have volume as 2, 1 and 2 because two volumes of hydrogen reacts with one volume of oxygen and two volumes of water. Now, according to the Berzelius hypothesis, we would have spoken in terms of atoms, but that's not the case. According to the Avogadro's law, we will be talking with respect to number of molecules. So, number of molecules is proportional to the volume, which means 2n, the number of molecules would be for hydrogen, n for oxygen and 2n for water. Now, which means two molecules of hydrogen reacts with one molecule of oxygen to give us two molecules of water. Similarly, let's take the example of hydrogen and chlorine to give us hydrogen chloride. Okay, so hydrogen, this is back to the first example, yes. Chlorine gives rise to hydrogen chloride. So here let's take the volume first. According to the Gay-Lussac's law, you have one volume of hydrogen reacting with one volume of chlorine to give us two volumes of hydrogen chloride. According to the Avogadro's hypothesis, the number of molecules would be 1n, so n, number of molecules n, then the number of molecules of hydrogen chloride is 2n. And if we assume, and we are dividing the whole thing by 2n. Okay, so when we divide the whole thing by 2n, we get 1 by 2 of the molecule, and 1 by 2 of chlorine molecule gives rise to 1 molecule of hydrogen chloride. Okay, so 1 molecule of hydrogen chloride will have half a molecule of hydrogen and half a molecule of chlorine. Now, half a molecule of hydrogen is nothing but hydrogen has 2 atoms of hydrogen. So, one of the atoms of hydrogen is combining with 1 atom of chlorine, which is again half the molecule of chloride, to give us hydrogen chloride, which consists of 1 atom of each. Okay, and this is Avogadro's law. So according to the Avogadro's law, similar conditions of temperature and pressure, equal volumes of gases contain equal number of molecules. Remember, Avogadro was the one who came up with the fact that the smallest particle might be an atom or it can be a molecule. An atom is the smallest particle of an element which may or may not have independent existence and takes part in a chemical reaction, whereas a molecule is the smallest particle of a substance. This substance means it can be an element or a compound, and this is capable of independent existence. With this, we finish the Avogadro's hypothesis. Do check out the next video, which is going to be about the mass and the molecular mass of various elements.